All right, everybody, welcome back. So today's lesson, if you haven't gone through it already, it's pretty self-contained. So what we do is we walk through the process of modeling a particular type of real object using the features of Java's object-oriented system that we've already been learning. So at this point, we spent the week introducing you to various, ways that we can model data using Java objects by combining state and behavior. And then last couple lessons, we looked at ways of kind of just making things more, convenient for ourselves through constructors, and then being able to control access to our classes through visibility modifiers to achieve encapsulation. So what we do today in the lesson, which I'm definitely not going to go through again, is just sort of actually pick like a real problem. And, again, it's sort of a silly problem. It's modeling tic-tac-toe, which I picked partly because we had already done some of the heavy lifting for this imperatively in the past. And so what I did is I sort of took that piece of code that we had for board checking and included it as a solution, so as part of this class that we designed. And when we're done with today's lesson, we have a class that you can actually use to play tic-tac-toe. And it obeys the rules of tic-tac-toe. It makes sure people take turns. It can determine when the game is over, things like that. And so, again, today's walkthrough, I'm really not going to go through and reprise all of that because I probably, it probably would take me the whole time, and it'd be fairly repetitive. I am happy to answer questions today about the previous material that we've been looking at this week. This is really important stuff. So next week we're going to kind of, we're going to keep practicing and reviewing some of these things, but conceptually we're going to be putting more in front of you. And so this is a good time, particularly as you go through today's lesson, to kind of make sure that the things that you're looking at seem familiar. Everything that we accomplish by the time we're done today, when we get to the end, should be stuff that you understand, right? Or I don't know about understand, but at least you've seen before and you can kind of puzzle through given the lessons that we've already been showing you. So there's nothing new today. It's just probably a more complete, a little bit more mature, longer sort of exposition that combines the ideas that we've seen already. Right. And also, I think one of the things that's fun about today's lesson is you get a little bit of exposure to the design process. So, let's see here. It's like there's some problems with the stream today. I know that YouTube was having problems yesterday. Okay, no idea what's going on here. If it's my internet connection or, well, I'm going to try to let it stabilize here and see how it goes. Anyway, if you have a question, throw one up in the chat. Otherwise, I'll probably hang out for maybe 10-15 minutes, just waiting to see if people have anything they want to talk about. I'm going to go put some tea on, but I'll be back in a second. So give you guys a chance to queue up anything that you want to talk about. So again, you guys have questions? Fire away. I am happy to answer them. Otherwise, it's going to be a short session. fine with me. It's a beautiful day. It's Friday. Trying to make the Tic-Tac-Toe run from VS Code. How to structure Java projects with. Do you mean with an IDE? Like how would you structure Java projects using an IDE, or? Yeah, I'm a little confused by the question. It looks like what you're doing is you're talking about you want to talk about using an IDE to do something like this. I think that's what the question is. But let me ask for clarification. Yeah, we could do this. So we're going to when we start the project in a few weeks, we're going to give you guys experience using. You don't want to use an IDE. Oh, okay. If you don't want to use an IDE, how would you? Yeah, I mean, so you can do that. So the if you don't want to use an IDE, okay. I guess my first question would be, why don't you want to use an IDE? For Java in particular, I would use an IDE. Just because they are now. I wouldn't use VS Code. I don't think VS Code is a particularly useful IDE for Java. I would use IntelliJ. I think the JetBrains family of products, which is really IntelliJ, and then also Android Studio, which is built on IntelliJ, are much better. So if you want to do that, we can do that. Let me see here. I don't usually do this, but let me pull up. Okay, so I need to change this. So I'm pulling up IntelliJ, and then what I'm going to do is figure out how to share my screen so you can see the IntelliJ stuff. Okay, here we go. That's weird. That's going to change in a minute. Okay, so if you're going to set up a project in Java, like I said, I would use IntelliJ. There's a fair amount of I don't know. Do I want to do this today? I don't know. Why not? Nobody else asked the question, so we can try it. There's our playgrounds are really designed to allow you guys to focus on writing code. That's why they're there. That's why we use them for things like the homework. I don't want you to have to worry about all of the cruft that goes into really setting up a real Java project. I really want to just be focused on code, right? Now there is all this other cruft, and to be honest, we just don't really teach it to you in this class because I don't think it's appropriate for beginners. Some of it is like a little bit frightening and scary and weird and stuff like that, and so we kind of just don't really go there. But since you asked, I'm happy to kind of try this. I don't even do this on a normal basis, so we'll see if I can actually even get it to work, right? So let me go back here. So again, my suggestion is if you want to use Java, use IntelliJ. It is, there's other options out there. There's Eclipse, there's BlueJ. You can use VS Code. None of them are halfway as good as IntelliJ, particularly for Java and other Java-like languages. I mean, IntelliJ, this is free software, by the way. I'm using the Community Edition, which is a free download. You don't have to pay any money. There is a professional edition that you can pay money for that has some extra features, but if you're just doing Java stuff, usually the Community Edition is totally fine. So again, like this is what I would suggest using. So let's try this. So we're gonna create a new project. All right, so I click on this. I don't know what's happening here. Okay, and now the problem is I gotta switch this around a little bit so you can see what's happening. Okay, so here's the new project window. I'm going to select this as just a vanilla Java project, okay? And when you set this up, there's some decisions to make here, like which version of Java you want to use. You need to have Java installed on your machine for this to work, right? So again, this is like one of the things that we just get away from by using the playground, right? It's all this like, I have to set up Java and which version I'm going to use and where does it go and how do I find it and does IntelliJ know about it and stuff like that. So the playground just keeps you from having to deal with all this stuff. I've got a couple of versions of Java installed on my machine. The latest one I have is 14, so let's just use that. That's fine. I'm going to hit next. I'm just going to hit next. I'm going to call this, we'll call this Tic-Tac-Toe, and it's going to create like a folder somewhere for me for this. And then when I'm done, now I need to switch this again. Let's go back here. Idea, new project. Here it is. Okay. All right. So here's my Tic-Tac-Toe project, and it's still in the process of initializing and stuff like that. I'm going to turn this off. This is a tool I have that we're not going to use. And so when you're done, all it really does here is set you up with a source directory that you can put Java files in. Now, one of the things when you start working with the real Java project is that there are different sort of project layouts that people use, like where stuff gets put, right? So like what folder do you put certain files in when you're developing in Java? We're really going to have one file here that we're going to create that's going to contain all of that Tic-Tac-Toe code. But let's see here. So let's put that. So there's this standard project layout that's used in these projects, and I need to remind myself what it actually is. Okay, so what people do is they say, we're gonna create new. Hold on a sec. I just want to create a directory. Let me go ahead and I'll just sneak around here and do that. So I need to go into my Tic-Tac-Toe project in the source directory. I'm going to make a directory called, how would I actually do this here? That's a great question. I never do this way. So you guys are challenging me today. Don't want a package. Why can't I just create a directory? Right, finding out how to do new things today. I'm just create files and directories. It's not working. Let's see, I'll right click. It's new. But there is no. Oh, I know what the problem is. Okay. This is how this is set up. Yeah, see. Why we don't do this way. Sources, source folders, okay. And then tests. There's no test source folders, so I guess we're just going to use source for this. That's fine. There are other project layouts that get used by different tools where they put things in different places, but let's just do it this way because this is kind of what IntelliJ wants. So I'm going to create a Java class. Now, one of the things we're going to see right away, I need to name this the same file name that I used for my actual Tic-Tac-Toe class. So I think I called this Tic-Tac-Toe game. And now here's my class. Now I'm going to go ahead and grab, let me make sure you guys can still see what I'm doing here. Yeah. Now I'm going to go grab the code that I wrote in this lesson at the very end, where we ended up at the end. Now, wait, no, sorry, that's the wrong thing. Okay. I gotta do this guy, gotta go all the way to the end. All right, so all I'm doing is I'm going to the lesson from the last walkthrough, and I'm cutting and pasting this code. Now, one thing that you're going to discover pretty quickly here, so I'm going to just paste this down here. So all this looks okay, but then there's all this anger down here. Let me also zoom in a little bit. Let's see here, in a presentation mode. Okay, so So if I go down here to the bottom of the file, what you'll see is that there's all like there's all this anger from the IDE saying that a class or interface was expected. This is something that's going to make more sense to us next week. So one of the things that our playgrounds allow you to do that normal Java code does not is they allow you to write what's called loose code. Okay, so loose code is code that appears outside of a class or a method. And in normal Java, we can't do that. All the code has to be inside a class or a method. So all this code down here cannot appear in our class. Now, once I get rid of that, it's going to be, it's angry about something here. Let's see here. I thought did I misname my class? Let me get out of presentation mode again. Exit presentation mode, okay. I must have put this in the wrong file. Tic-Tac-Toe game.java. Oh yeah, I screwed up. I just messed up. It should be Tic-Toe Tac. I created a new game called Tic-Tac-Toe refactor. Okay, so now it's happening. And that's something that when you work outside of our playground, Java enforces this. So there's a couple of rules that Java will enforce that may be new to you, right? One rule is that in a file, if the file is named Tic-Tac-Toe game.java, it can only contain one class, and that class has to be named Tic-Tac-Toe game. So I can't even create another class in here, I'm pretty sure. Like if I try to do like public class another, let's try to create another class in here. Yeah, so it's going to be mad. It's going to say that I need to put this in a different file. So typically when we create, when we're actually working with the real IDE and our stuff is stored on a real file system, we have this limitation that I can only create one class per file. That's something else that our playground allows you to get around with, and that's really convenient, right? Because if we had to have like one class per window, particularly a couple days from now, once we start to work with multiple classes together, that would become very inconvenient. And so, okay, so this is all the code, and you can see like it's pretty okay. Like there's a couple of things here that are kind of like, so it's claiming that some of this is unused because there's no place in my code where I actually do use this. So now we actually have the code. The question becomes how would I actually run this code, right? So I can, right now, if I wanted to, I could compile this Java code and I could, but there's no real way to execute anything, right? There's no, because I can't write that loose code that I had written before outside of my my method, right? I can't. So the question is like, where do I put the code I actually want to run when I run my class? And this is something else that I'm getting a little bit ahead of myself here, but we will talk about this. And why does Java enforce one class per file? I don't know. I think it's really stupid, but I think maybe it's too. So one of the things that Java does that I think they thought was a good idea at the time, but turns out to be kind of a stupid idea, is that in Java, there's a relationship between where things are on your computer, on the file system, and their name. And that actually extends to another concept that we haven't gotten to yet and won't get to for a little while, called packages. And so the idea is that, given the particular package location of a class, it has to be in a particular spot in a particular folder. And that actually becomes a huge pain in the butt. And some newer variants of, I shouldn't say variants of Java, some newer languages that have that interoperate with Java but are not Java have relaxed that requirement. And it turns out to be much, much more convenient. Because there's sometimes where it's like, you want to create a class, the class has 2 fields. It's like, I don't want it in its own file. It's like 5 lines of code, right? So anyway, I don't know, right? It's just what Java decided to do. Okay, so now we've got our code here. So again, the question is like, let's say I want to run this code. How do I do that, right? And so one thing we can do, I'm sure I could get the IDE to do this for me. Actually, it probably wouldn't, right? So let's actually see if we can at least compile this in IntelliJ. I don't know exactly how to do that. Well, here's what we're going to do. we're actually going to add what's called an entry point. So the question is, if I was actually going to compile and run this code, what would actually get run? So I've got all the parts of my class, but there's nothing using the class. And so what I want is I need a place to put all this stuff down here, like the loose code that I was using to make the game go. Actually, you can't see this because it's my other thing, but I'm going to cut and paste it back in here. So the question is, I'll put it under a comment so things don't get angry. Where do I put all this loose code that was in my file before that my playground allowed me to do, but real Java doesn't? And so what I do here is I create this, and some of you that learn Java in high school like know all about this because your teachers didn't use the same approach that we use, and they had to show you this all right away. So we create this, public static void main, this magic method that takes an array of strings, and I'm going to mark this as unused because we're not going to use them. This now is what's called the entry point. So when I run the code, this is where the execution is going to start. And there's all sorts of things about this that I don't expect you to understand, like what is static, for example. We'll talk about static next week. But for now, all I want to point out is that this is the place where I can put this loose code, okay? Now, one thing you might notice, and it may be hard to see because the display might be a little small, but when I did that, IntelliJ put a little play button next to this method because this allows this class to be runnable. So now I can actually execute the code in here. And let's do that. Let's click run. So when I click run, what's going to happen is first, IntelliJ is going to compile the code that I wrote, and then it's going to run it starting at this main method. And look, check it out. This is output that's pretty much the same. I don't know what the heck this is. Whatever, it doesn't matter. But starting after that, there's output that's essentially the same as what we would have seen on the playground. And we can do this in the playground as well, actually. Starting again, next week, we're going to fully take all the training wheels off the playground for you. And what we'll do is we'll actually have a lesson where we're going to talk about this exact same thing. Like, what is this main method? Why do I need it? And after that point, you guys won't be allowed to write loose code outside of classes anymore. This is a trade-off, right? And this is something that we decided to do as part of CS 125 because I really, so the alternative would have been on day one, I would have had to show you a class that had a public static void main method because that's the only way you can get anything to happen in Java. I decided not to do this because I want to start small. I want to show you just variables and how to manipulate them, and then just methods, and then just simple examples of classes without all the gobbledygook. But eventually we'll get to the point where you guys are writing things that you could literally cut and paste into IntelliJ and get them to work. So there it is, right? So we've done this now in IntelliJ. Like I said, this is I use this a lot for Kotlin, which is a sort of a variant of Java. Again, I shouldn't call it a variant of Java. It's another language, but it's a language that interoperates with Java. IntelliJ is a great tool. I mean, it's by far, I would say, the best IDE for Java that exists. So there's that. Anyway, there it is. Now this is actually a great question. So one thing I think, let's try this. Let's try actually having X go twice, and let's see what happens and see if this was actually going to break. Yeah, okay, so you'll notice that, remember before, I had this assertion to make sure that X doesn't play twice in a row. And you'll notice that I just caused X to play 3 times in a row and that assertion didn't fire. So the question is why? And the reason is, and this is again something else that's unfortunate about Java, these assertions that you put in your code don't always work. You have to tell Java when you run the code that you want those assertions enabled. And I'll show you how to do that just so we can kind of reproduce the same behavior that you would see in the playground. So I need to go in here and I need to edit the config. So as soon as I ran this, IntelliJ created what's called a run configuration that allows me to run this again. And basically this is just something that now I can hit play and it'll do the right thing and it'll run the class for me. One of the options here says VM options. And the -EA stands for enable insert assertions. And so this will cause assertions to be turned on when I run the code. So now when I run it, what you're going to see is the assertion fired, right? So you'll see that player 0 should go next, and it's taking me back and has a nice stack trace here. So where did this come from? So I tried to make a move on line 66, but player X was going again, and the assertion turned on. So again, these assertions that we've taught you how to use don't come out of the box in Java. And this is another one of these things about Java that I just don't understand. But there it is. But they're easy to turn on, as I just showed you. You just have to add this option. So now when you run Java as part of this configuration, you'll get the assertions turned on. The reason behind this, if you might wonder, like, why aren't assertions always turned on? Assertions take time to run, right? So it takes time for Java to actually run the code that's contained in an assertion. For that reason, sometimes people will only use them during testing. They'll only use them when they're actually testing their code, and they won't use it when it's in production. So you imagine, like, you have some tests that you run, and we're going to show you how that works. Once you start working on the project, we'll have tests for you to run, and those tests are going to be how we grade your code. So you run these tests to make sure your code is correct. When you're testing it, you turn on the assertions so that stuff breaks, and then when you're all ready and you've got your shiny new app that you're about to deploy, you turn off assertions. And the idea is that when your code is running in production, like it's being actually used by a real user, they don't hit those assertions. And is that a good idea? I don't know. I mean, I tend to like to have assertions on. I think the overhead of assertions is probably pretty small. Maybe back in the day when computers were a lot slower, this was a better design choice. But again, it's one of those things about Java. It's a little weird. But yeah. Let's see, if I was to write the same code for production, would I place? No, so the idea here is that the assertions are designed to make sure that other people are using my code properly. There are other options here, right? And we're going to talk later in the class about another thing that you can do in this case, which is called throwing an exception. And we'll get there, right? So assertions are actually one way of throwing an exception, but there are others. And so you can actually throw various types of exceptions. So for example, I'll just show you this for fun. And again, like stuff way down the line, not expected to know this now, but you asked. And so I could say something like this. I could say, instead of the assertion, I'll say if not player, then what I'm going to do is throw new legal argument exception. And then I'll use this as the message. And so what this does is this causes an error to happen. So one of the reasons why assertions are sort of nice is you see that the assertion syntax is a lot more compact, right? But this will also work. So now I'm essentially saying if you give me a bad player, I'm going to throw this legal argument exception. Let's see that in action, okay? So let's use a bad player here on the first line. I'm going to run this. And you'll see that it says exception in thread main, a legal argument exception, bad player A. This, and I'll go back and edit this configuration. These exceptions are turned on even when assertions are not, right? So again, I just ran it again without assertions turned on. And so this exception that I'm throwing is still hit. And again, we'll talk about that later, right? We'll get there. Right? Exceptions are really cool and a lot of fun to think about and work with, but we kind of get you a little farther down the road first before we introduce this idea. But this is kind of how you would do this. Now it sort of depends, right? Like if you're making this available to other people, I would probably say you want to use this pattern because it always works, both in when you have assertions enabled and when you don't have them enabled. If this is part of code, like let's say you're building your own app that allows people to play tic-tac-toe, if this is part of that app and it's only being used by you, then the assertions are really there to help you. And so you can basically kind of have them there to help you during testing and then let them be turned off in production. So that would be okay. So it really depends on who the audience is for the code. If the audience is you and you're not making this code publicly available to anyone who wants to create a tic-tac-toe game, then by all means, use assertions. If the audience is like some other fool out there who's probably not going to read your documentation, then I would probably throw an exception. But again, we'll talk about exceptions later in class. Really interesting questions, though. Yeah, IntelliJ is awesome. Can we post? Yeah, we can do that. We can post both. We'll probably start doing the We'll just start posting both weekend problems. I don't think I've actually written the problem for Sunday yet, though, so I guess I should do that. It'll be similar to the Saturday problem. So, yeah. So okay. So now since somebody asked about not using an IDE, let me show you how to do this without an IDE just for fun. And I'm going to need the same code. All right. So I'm going to take this code. I'm going to cut it. This is working for me. And then I'm going to make IntelliJ go away. Bye-bye. Now, again, don't do this. IntelliJ is great, right? Particularly for Java, IntelliJ will really, really help out. So let me show you one example of something that you get with IntelliJ, right? So, for example, IntelliJ knows that this is what type of object this is, and so it's able to suggest. Can you guys still see this? Yeah. No. Hold on. Let me get rid of this. I need to fix this to use. Here we go. Like, IntelliJ knows that new game is a tic-tac-toe game, and so it can suggest various things that I might want to do, like call get winner or make move. Now, one of the reasons you're seeing functions that aren't public is that this code is on the same class. So if I was using this in another class that was running the game, I would only see the make move function here. And so again, IntelliJ pops up a nice tooltip that tells you what the function name is, what the arguments are. If you had documentation for the function, it would also show that. So this is really useful, right? Okay, so anyway, but I'm going to copy this and I'm going to close IntelliJ. And now, just I think this is kind of a fun thing to do, just so you guys see that it's possible. All right, I'm going to open up a terminal. I'm going to make the font really large, and there it is. Okay, so there's my terminal. Let's see. I'm going to go into that. I'm basically going to go ahead and remove this directory I just created that had my example in it, and I'm going to remake it. I kind of show you how to do the same thing using just. I need to be able to spell. Tic-tac-toe. There it is. Okay. So now I'm doing this from the command line, which is something else that I can do. There's no files in here so far. And I'm going to create my file called tic-tac-toe game.java. And I'm going to actually go ahead and insert all the code that I just written. So you'll see I'm using a file editor called Vim. Vim is really just a text editor. It's not an IDE. And so you'll see that it does do some things that an IDE does. So it can highlight syntax, for example. It understands, sorry, turn this off. It understands indentation. Actually, I have this, it thinks I have this improperly indented. It should be 2. It likes 2 spaces. So I just re-indented the whole file. So, it understands indentation in source code. Like when I try to add something here, it puts me at the right level and things like that. But it's not an IDE, right? So it doesn't do things like autocomplete, and it doesn't check for certain problems that IDE will check for and stuff like that. But I can use this, okay? So I'm using this to just rebuild the same content that I had before. Now in this directory, I have this file called Tic-Tac-Toe Game. And now we can essentially apply the same set of steps that we were applying before. Unfortunately, the version of Java here that I have is Java 8, so just let me fix that. Let's see, versions. What I'm doing is I'm using a tool called JM to set the Java version for this directory to be Java 14, and I'm going to check it. I could run this at Java 8, it would work fine, but I might as well use the same version of Java that we were using before. So now I have this file, and now let's Java C it. There it is, right? Works. The compiler didn't find any problems. The compiler produced this file called tic-tac-toe game.class. That's my compiled bytecode. And so now I can run this. I can run Java tic-tac-toe game. And now I see the same output, and this is because I have this problem with the game logic that I need to fix. So let's change this to O. Oh, actually, no. Let's change this to X, and we'll change this to O and X and O. Well, actually, let's have X make 3 moves in a row, and I'll show you how the assertions work. So I need to recompile the game because I made a change. Now if I run it, you'll see I see the output, but I also see that X played 3 times in a row, which is not what I should have allowed. if I want to turn on the assertions, and I did this in IntelliJ, but if I want to do it from the command line, I have to pass this flag to Java, at which point that assertion turns on and gets hit. And so I can go back to my my file, and I can change the second move to O, and I can save it. I have to recompile it because I changed it. Now I'll rerun it with the assertions on, and I see the output that I expected. So anyway, this is an example of doing things in probably like the most minimal way possible. I would not suggest that you do this because, you know, when I was a kid, 20 years ago, when I was learning how to program a lot, we made do with them. They were okay. I still, you know, will use Vim from time to time to edit a file and under certain circumstances. But whenever I'm doing work in a Java project or a Java-like project, I'll use IntelliJ. It's awesome. I mean, I'm not one to like, you know, be a fanboy of IDEs or whatever, but IntelliJ is just a really good tool. It's way better than VS Code, I will say, and I suspect way better for Java. I've actually never even tried to do any Java in VS Code, but my experiences in using VS Code for other languages have led me to believe that it's just not as sophisticated. IntelliJ is slower. That's probably a fair point, but it's slower because it's doing more to help you and to kind of find structure in your code and stuff like that. So, so essentially, you know, like, you know, when I opened up IntelliJ, you probably saw, you know, I've got a bunch of projects in there, and I work on those every day. I was working on one this morning, so that's really the tool that I use whenever I'm doing any Java-like development. It's really nice stuff. All right, any questions? More questions today? Questions, comments, anything like that before we kind of part ways today? Standard way to test how well a program is written. No, it's all right. I mean, it's a great question. So cue that one up for next time. We'll talk about it a bit more. The answer is there's really two things, right? Usually when we test your code, and this is definitely going to be true for the project, we don't care about efficiency. We care about whether it works or not, right? Does it actually do what we asked you to do? That is probably the first order bit, right? Like if you don't solve the problem, it doesn't matter how fast your code is. I can write really, really fast code that does nothing, right? You know, so it's like you know, your employer asks you to build an app to track COVID-19 on campus or something, and you just give them like a blank screen. It's like, yeah, it's super fast, right? So, you know, until you meet the problem requirements, performance is usually something that, particularly today, given how fast computers are, don't worry about it, right? There's this, I was just talking with some colleagues about this the other day. I mean, there's this trap of doing what's called premature optimization, where people start to try to improve the speed of their code before they're even finished with it. You know, don't, right? Finish the job. Then, if there's problems, you can go back and optimize it. I mean, I have to say, I mean, when I was working on the website and other stuff for this class, there's a bunch of places where I was like, uh-oh, I wonder if this is going to be too slow or, you know, use too much of the network or something. And I just was like, you know what? I've got too much other stuff to do. I'm just going to like finish this up. I'm going to do it in a straightforward way. And then if it turns out the students start complaining, then I'll go back and I'll fix it. And so far there haven't been any complaints. And so some of that stuff turned out a lot better than I thought it would. So a lot of the testing that we'll do in this class is you know, testing the functionality of your code, not the. Now, if you want to actually start doing more performance-based testing, absolutely, there's lots of tools for that, right? Tools that will measure how long it takes for your code to do a particular thing, how much memory it takes. But those are usually, especially today, very much a second-order concern. I mean, you can build really cool things and change the world and have a huge impact as a computer scientist without doing a lot of optimization. And the reason is just, you know, computers are so fast today, and that's something that we should all thank the electrical engineers for and or the computer engineers for, and just really take advantage of in our own code. All right, thanks for joining me today, guys. I will see you next Monday. I hope you have a great weekend.